Hello, everyone. Let's get started. Please download the Laboratory 27 from Blackboard. And today we are going to learn linear regression model. Okay, as usual, you need to run the first script and input your name, your number, the title, and date. Okay. So first, linear regression model is very, very important in this data science class. So first, we need to learn some terminology. Perhaps you have already known, right? So linear regression is it's a technique to predict some variables based on a data set, right? And the predictor variable, they help predict the value output variable, and the output variable is something you want to predict, right? It's also it's commonly referred to as y. Estimate y as linear regression model, we need to use this y. Ye means estimated y, right? It's based on a linear regression model. So you in mathematical formula, you learn how to set the like alpha and beta, slope and interception to construct a linear regression, right? In this class, we use codes. We write Python codes to find the parameter like the alpha, beta, the intercept, and the slope, interception and the slope to construct this linear regression model. Okay, so how to estimate alpha and beta? First, and into this class, we will use a method called ordinary least squares, OLS. For instance, here, the red dot, they are raw data, and then you need to find a linear regression, a linear line, right? A line which is similar, which used to fit all the data, right? Data point. It's a curve fit. So here with the objective of the least squares, it find the value of alpha and beta, minimize the sum of the squared difference between y and ye. So it means the square of this distance, right? So we can use this formula to compute that based on that, right? So like compute the sum of xi minus the mean value of y multiply yi minus mean value of yi, and divided by the square of each difference. And after that, you can compute the interception. It's about the slope, right? So it's about the covariance. Covariance is very important terminology in mathematics, also in today's class. So covariance formula you can learn from here is very similar to the formula of the beta, the slope, right? Only difference is the fraction here is different. Okay, correlation, positive, 0, and negative. So it's about the correlation. Yeah, so yeah, let's see some concrete examples. First one, actually this alpha and beta, you can use it, you can compute these values based on some functions. But first, we don't want to use the functions. We want to write the codes with only basic Python codes to compute them by ourselves. Okay, and after that, we use the functions to do that again. Right? We had a table of these times and speeds. All right. So first of all, you need to import necessary packages, NumPy, pandas, statistics, and matplotlib, right? Right. And create a data frame. Use a dictionary to create a data frame. Two lists, right? And then use a dictionary and print out this data, right? Time and speed. But this one, necessary packages, create a data frame, And after that, you can explore the data, print out some statistically feature of the data, mean value, count, standard deviation, minimum and maximum, right? And after that, you can use the you can compute something interesting. So because from this from the formula here, you need to compute beta as this one, right? But it's related to the covariance, so we can compute the variance first, right? Variance, and you can use the statistics dot function to compute the variance, time and speed, right? So this covariance for the time list and speed list, right? And after that, we need to figure out the relationship between the time and speed. So we need to use covariance, not only the variance, right? So you can use data dot covariance, and then time and time. Here, the first one is time and time, and actually, the covariance between time and time is exactly the variance of time, right? Because the two variables are the same. So this one and the last one, they are only the variance of the same data list. But for the second element, or the first element of the second row, is different. It's the covariance between time and speed. Okay. And after that, we can use the Pearson method to compute the value here. Covariance, correlation coefficient, right? So it's about the time and speed. It's defined here, right? So coefficient is used to measure how they are positive, zero, or negative, right? Clearly, here is very positive. If it is positive, it's 1, and the speed is 0.96. It's pretty positive. So after knowing that, we can do the linear regression model with only the basic Python codes, right? Estimate Y, use OLS method. We need to compute mean value first, and Y mean first covariance, the variance to compute that. So first one, X mean will be the mean value. Use the numpy.mean, or you can also use a statistics.mean value. .mean function is the same, right? And after that, we use the data, compute the terms needed for the beta, right? So first one, data one, so you need to check here, okay? The first one, each element of X list minus the mean value, multiply Y minus Y value, and the second one is about this one squared, right? So that's why here we need to compute. The first one is each element of the time and minus the mean of the time, multiply. The second one is about the square of each element. Okay, and so the beta can be computed as the dot sum divided by this one dot sum, right? So you can learn from here, right? Sum together, right? Yeah, so after that, alpha is defined by Y mean minus beta multiply X mean. So F alpha, F beta, you can compute it by yourself, right? So alpha is this way and beta is 11.97. So it is about the linear regression model. If you have already got the alpha and beta, then you can construct the linear regression model, right? The next one, because we have already estimated for alpha and beta, our model can write in YE is this is beta, right? Slope, interception. So we can make predictions. And X is the time, right? X is the least. And then y is defined as this function, and actually y prediction is also a list because x is not only one number, it's multiple numbers, it's a list, right? So from this list, you can print out the ye actually. It's a group of data, right? Spot for each one. And actually in this data, this one is a raw data, right? And in this way, we calculate the estimated y data, right? It's about the linear regression model. Yeah, so, and you can also plot the prediction y predicted against the actual data and get a better visual understanding about the model. You can use this way to define a figure and plot. You can plot two different things, right? The first one is a regression line, and this one, x-axis would be x, the y would be y predicted. Actually, x would be the time. It's the same, right? I think you can reverse as time. So to avoid the misunderstanding, okay? So they have the same x-axis, but different values. Y predicted, and the color is red. It's a red line, right? And next one is speed. Speed means the raw data. And in this way, we use a scatter plot because they are not continuous. They are only some dots here. So we use blue dots to represent them and set X label, Y label, and title. Show it. See here. The red line is something you just compute, right? Red line is this one. And the blue one are raw data. Blue one is this one, these two, okay? We use this one to plot the scatter plot, blue one, and the red line, okay? All right, so any questions so far? All right, next one. The right line is our best fit. So you can see from here. And it's a positive linear relation between x and y. So use a model, we can predict y from any values of x. So for instance, you can use 20, so predict the value. The speed would be 222 when the time is 20, right? So it's used to predict something. So for now, perhaps you think it's very, very hard to write the codes, right? Because you need to compute the mean values. You need to compute the this difference by yourself, right? And then you need to check the formula and compute the beta and the alpha. Then you know the linear regression model, right? But actually, you don't need to do that. You can learn to use some good functions here. You can use a statistics models. So we can use a statistical models to construct this model. You can use OLS function. Actually, OLS, ordinary list of squares. Do you remember that? This one, we use a method called OLS, ordinary list of squares. So it's written in this package. Then you can use this pattern to set y is something you want to predict, and x is a predictor, a variable, time and speed. Then you can use this formula, right? You can use statistics formula API SMF and set the function, because there are many different methods to construct a linear regression model. In today's class, we use the ordinary least squares OLS method. So that's why we need to use this function, OLS, and then speed is something you want to predict, right? And time is something you want to analyze, and data is data. Data is an argument. Then here data, because data is something you create the data frame, right? You need to pass a data frame, data. And please make sure you use the right name. Okay, so it's sensitive to the like uppercase or lowercase. Please remember. For instance, here, right? And I think if you use speed, perhaps it works, but the result would be different. Okay, so please make sure to use the right one, uppercase S and speed time. So it's based on the data frame you create. Okay, so if this one is a lowercase, you can use lowercase here. Okay, and if you use this way, model is just you initialize. You just initialize this model, and after that you need to use a model fit to train this model by itself. Okay, and after that, you can get the parameters. Alpha and beta have been done by the function. So intercept and time. So it means it's the beta and it's the alpha, right? You can check the results with here and here. You can find it. You see, it's exactly the same, but you don't need to do all of them by yourself. You can just use OLS, only 3 lines, right? Only 3 lines. You can get the alpha and beta to construct the linear regression model. And after that, you can compute, you can .predict, use a .predict to get the predicted values and plot them together. See, it's the same one, right? It's the same figure with the last one. So yeah, it's how to use the statistics model package to construct a linear regression model in ordinary least square method. It's very simple, right? Because in this one, you only need to initialize the model, fit the model, get the result, or get the prediction. So that's it. Yeah, so it's very easy, right? Okay, so any questions so far? Any errors? We run cells. Okay. So yeah, that's today's what I want to share today. Please run all the cells and finish this exercise. Okay, so we have 2 exercises today. So list some pros and cons of the linear regression. You can start something because actually in some data they are not fit for linear regression model. They are not linear, right? They are perhaps they are different models, but yeah. So please list the pros and cons. And second one, how good do you feel about the predictive model created into this sample? Will you trust it? Explain by use the plot. You can check the plot. You can like check the difference here, right? Difference here, and show you will you trust it or not, and explain it. All right. Okay, so that's all I want to share today. And yeah, so if you don't have any other questions, please feel free to leave the meeting. Thank you. Have a nice day. If you have questions about today's class or the grades of your homework, you can stay here. Yeah, thank you.